In this section, we're tasked with performing a frequency response of the circuit diagram here. We wired it into our breadboard. Here is equivalent to our 9 kilo ohm capacitor. It's actually 8.95 k ohms. This is equivalent to our 1 k ohm capacitor. It's approximately 0.995 kilo ohms. And then this is our 0.22 microfarad capacitor. We're checking the output from ground to the junction between the two resistors networks. Our blue probe here is viewing our output on our oscilloscope. Our green probe here is viewing our input from the function generator. On the function generator, what we started with, it was a sine wave at 1 kilohertz, and we set the amplitude to the 2.83 volts shown here on the screen. This gives us a 2 volt RMS signal to our circuit. Here, shown on the oscilloscope, is the input and output waveforms. To determine what the phase angle is, we take 360 degrees and divide it by our period, shown here as 1 millisecond. To do this, we can come into our calculator and take 360 degrees, or 360, divide that by 1000 to give us 0.36. Next, we determine where the time delay is from our input to our output. Right here, we use the cursor to find our 0 point of our input and the 0 point of our output, and then found the difference between that is 86 microseconds. And we take 86 and multiply it by that 0.36 that we just found to give us 30.96. That is going to be our phase angle shift. It is a positive number because our input is 30.96 degrees ahead of our output. Our values here are slightly different than what the oscilloscope reads, but the oscilloscope reads averages where we're finding specific numbers. So our difference is about 3 to 3.5% variance.